Okey, Assalamualaikum warahmatullahi wabarakatuh semua. Okey, selamat pagi. Okey, apa khabar semua? Okey, sekarang pukul 8.14. Okey, saya tunggu lagi seminit. Saya akan start terus pukul 8 suku. Kita tak tunggu. Okey, tolong panggil kepada kawan awak yang dekat kat Telegram ataupun dekat group. Okey, minta dia stream sekarang. Kita akan mula kita punya presentation hari ini. Okey, so kita saya akan pakai video untuk kedua-dua kelas. Okey, itu SH 15 dan 03. Okey, F03. So saya akan play semua video bagi pair untuk semua orang. Okey, so tugasan awak pagi ni watch the video. And setiap group yang present tu nanti macam biasa you bagi simple question dekat ruangan komen. Okey, untuk share dengan kawan-kawan awak, untuk kawan-kawan awak jawab dan respon, you akan respon nanti. Okey, dua-dua kelas pun sama. Okey, so setiap group kena prepare lah dengan soalan. Okey, so seterusnya sebelum kita start kelas kita recite doa dulu. Okey. Okey, pelajar yang hadir, tolong komen kat ruangan sini. Okey, saya akan mulakan video dan group syukriah untuk 7.1 dan 7.2. So, group syukriah tolong prepare dengan punya soalan ya.
Hello and Assalamualaikum to Madam and my classmate. For today's video, I would like to cover 7.1 Structure of Carboxylic Acid and 7.2 Aliphatic Nomenclature of Carboxylic Acid. First and foremost, the functional group of carboxylic acid is carboxyl. This is the functional group structure of carboxyl, where C double bond O attached directly to your COH. Bear in mind, the double bond and the OH must be attached to the same carbon. At the front, the carbon can attach with R group. It can be either straight chain, branches, or cyclic. Next, we move on to give a name for carboxylic acid structures. First, we have aliphatic carboxylic acid. There are three things that you should know before naming the aliphatic carboxylic acid. Number one, you must find the parent chain, which is the longest chain, continuous carbon chain that contains the carboxyl group. Nombor satu ni dia suruh kita identify dulu manakah rantai terpanjang di dalam compound ini. So, ini merupakan rantai terpanjang dalam compound ini. Number two, you should name the present chain. Name the compound as you normally would in alkene, then drop the E letter ending and replace with oic acid. So, nombor 2 ni suruh kita identify berapakah karbon di dalam parent chain compound ini. So, di sini ada 1, 2, 3 dan 4. So, nama ia akan jadi butane. Tetapi huruf E kat belakang butane tu kita kena ganti dengan oic acid. So, nama baru ia akan jadi Butanoic Acid. For the third one, number the parent chain where other substituents are present. The carboxy carbon is assigned as position 1. Number the substituent from the carboxyl carbon 1. So nombor 3 ni, so kita tulis nombor bermula dengan karbon yang attach dengan carboxyl group, iaitu yang ini, karbon ini. Tulislah nombor 2, nombor 3 dan nombor 4 supaya senang untuk kita tulis nama bagi yang ada cabang ni. Furthermore, we look at aliphatic dicarboxylic acid. This time, if two carboxylic acid groups are present, the compound will be named as alkene dionic acid. Maksudnya di sini, kalau terdapat dua kehadiran kumpulan berfungsi carboxylic acid dalam satu compound, nama belakangnya akan jadi dionic acid. In addition, we have for aromatic carboxylic acid. For this, when carbonyl group attached to an aryl group, the parent name is benzoic acid. Maksudnya di sini, apabila kumpulan aryl di sini iaitu CH3 dan benzene bercantum dengan kumpulan karbonyl iaitu COOH, parent name-nya akan dinamakan sebagai benzoic acid. Other than that, we also have aromatic dicarboxylic acid. For this compound, an aromatic dicarboxylic acid is named as 1,S benzene dicarboxylic acid. Contohnya di sini, jika terdapat dua kumpulan berfungsi yang bercantum pada benzene ring, automatik nama di belakang bagi compound ini akan menjadi benzene dicarboxylic acid. Lastly, we have cyclic carboxylic acid. For this compound, a cyclic carboxylic acid is named as cycloalkane carboxylic acid. Contohnya, jika terdapat cyclic carboxylic acid di dalam compound, contohnya macam ni, automatik nama di belakangnya kita akan tulis sebagai cyclohexane carboxyl acid sebab dia ada 6 karbon. Next, the carbon atom which is attached to COOH is numbered as C1. So, karbon yang bercantum dengan kumpulan berfungsi carboxylic acid akan menjadi karbon pertama dalam rantai terpanjang tersebut. The last thing that we're gonna learn in this subtopic is common names for carboxylic acid. So the first Aliphatic name you come across is Butanoic acid. Butanoic acid is usually known as formic acid that be used in paper industry. This is the formula structure for Butanoic acid, where the carbon attached with double bond O and directly attached with OH and H. Next, we have ethanoic acid. Ethanoic acid are usually known as acetic acid. It's mostly used as chemical solvent. This is the formula structure for ethanoic acid, where the carbon attached with double bond O and directly attached with OH and other carbon. Lastly, we have benzene carboxylic acid, or common name is benzoic acid. Benzoic acid commonly used as antimicrobial preservative in food and beverages. This is the formula structure for benzoic acid, where the carbon attached with a double bond O and directly attached with OH and benzene ring.
Okay, sorry. Saya bercakap tapi tak buka mic. Okay, siapa yang present ni? Boleh bagi tahu saya tak? Boys ni, kelas apa tu? Kelas ESH 15. Boleh bagi tahu ada soalan tak nak share? Grup Syukria ada soalan? Syukria ada soalan tak? Ni Syukria tak masuk lagi ni. Okay, ada soalan? Okay, tak ada, tak apa. Itulah markah lah. Okay, saya akan berikan video yang seterusnya daripada grup apa tu 03 pula. Okay. Check. Tak ada. Okay, so kita tengok daripada grup Livina 7.1 dan 7.2. Okay.
Be presenting subtopic 7.1 and 7.
Okay, sekejap.
Assalamualaikum. So today we'll be presenting subtopic 7.1 and 7.2, which is the structure and nomenclature of carboxylic acid. Here are the learning outcomes. Students should be able to give the general structure formula of carboxylic acid and draw the structures and name the carboxylic acids according to Aliphatic nomenclature. The general formula for a carboxylic acid is RCOOH or RCO2H. Next, we're gonna learn how to name the carboxylic acid. For aliphatic carboxylic acid, first we have to find the parent chain, which is the longest continuous carbon chain that contains a carboxy group. Second, name the parent chain. Put oic acid at the end of the compound's name. And to number the parent chain, the carboxyl carbon is assigned as position 1. So here's an example for butanoic acid. Since it has 4 carbons, so it's butanoic acid. And we can see that the carboxyl carbon is assigned as position 1. Here's another example. 3-methyl butanoic acid. The carboxyl carbon is also assigned as position 1, so therefore the methyl is at the carbon 3, and therefore the name of this compound is 3-methyl butanoic acid.
For aliphatic dicarboxylic acid ni, if 2 COOH groups are present, the compound will be named as alkane dioic acid. For example, pentane dioic acid, dia ada 2 functional group. Same goes to 3-methylhexane dioic acid. Dia pun ada 2 COOH groups. Next, aromatic carboxylic acid ni, bila carboxy group tu dia attach to aryl group, parent name dia akan jadi benzoic acid. For example, 4-chlorobenzoic acid and 2-methylbenzoic acid. For aromatic dicarboxylic acid ni, nama dia akan jadi 1X benzene dicarboxylic acid. For example, 1,3 benzene dicarboxylic acid and 2-isopropyl 1,4 benzene dicarboxylic acid.
Jadi, IUPAC nomenclature bagi cyclic carboxylic acid ada dua. Yang pertama, 1-COOH group. IUPAC nomenclature mestilah bermula dengan cyclic dan diakhiri dengan COOH, seperti cycloalkene carboxylic acid. Bagi 2-COOH group, IUPAC nomenclature mestilah bermula dengan 1, X sempang cycloalkene dicarboxylic acid. Seterusnya, mari kita lihat contoh bagi 1-carboxylic acid group. Rajah menunjukkan cyclopentane carboxylic acid. Pengiraan kita hendaklah bermula daripada karbon yang di-attach dengan carboxylic acid. Dari sini, kita dapat lihat bahawa ada 5 karbon, iaitu pentane. Jadi, penamaannya ialah cyclopentane carboxylic acid. Seterusnya, bagi 2-carboxylic acid group, rajah menunjukkan 4 chloro 1,2 cyclohexane dicarboxylic acid. Pengiraan juga bermula daripada karbon yang di-attach dengan carboxylic acid. Dari sini kita ada 6 karbon dan 6 karbon menunjukkan bahawa ia adalah hexane. Seterusnya kita ada chloro. Chloro mestilah berada di hadapan dan juga kita ada 2 carboxylic acid dan perlu meletakkan dicarboxylic acid. Seterusnya, common names for carboxylic acid. Common name formic acid. IUPAC name dia adalah Butanoic acid dan struktur dia seperti itu. Common name acetic acid. IUPAC name ethanoic acid dan struktur seperti ini. Dan juga common name dia adalah benzoic acid dan IUPAC name dia juga benzoic acid. Dan ini adalah struktur dia. Sekian, terima kasih.
Okay, good job untuk Nur Ibina, Nur Alina, Umaira and Syuhada Kis. Ada soalan? Ada tak soalan, Irina? Boleh respon kat komen kalau ada. Okay, tak ada. Okay, saya ada bagi link untuk link kehadiran. Okay, saya saja buat double check. Okay, jangan share dekat mana-mana. Just siapa yang hadir je dia akan notice link kehadiran ni. Okay, saya akan check nanti selepas ni. Okay, baru ada 35 orang yang watching ni. Belum bagi tahu kawan-kawan lain supaya join ya. Saya boleh trace nanti. Okay, saya akan trace melalui ruangan komen and punya link. Okay, seterusnya saya proceed dengan presentation dari grup okay, kita tengok dari grup 7.3 and 7.4 daripada grup Fahana Amira. Okay, so dengar baik-baik punya penyampaian.
Carboxylic acid
Today I would like to present about carboxylic acid for the subtopic 7.3, which is physical properties. So the learning outcomes for this subtopic is, at the end of this lesson, students should be able to compare the boiling point of carboxylic acid within the successive members with alcohol. Assalamualaikum. So today I would like to present about the carboxylic acid for the subtopic 7.3, which is physical properties. So the learning outcomes for today is, at the end of this lesson, students should be able to compare the boiling points of carboxylic acids with successive members and with alcohol. And the second is compare solubility of carboxylic acids in water. Physical properties of carboxylic acid. The first one for the boiling point, compare within carboxylic acid. So kita kena compare dengan functional group COOH juga. And the second one is compare with alcohol, which is OH. Second one is solubility in water. And the third one is factor that affecting the property strength is special characteristic of carboxylic acid, which is has hydrogen bonded dimer and ability to form hydrogen bond with water. So the effect of dimer structure in boiling point. Carboxylic acids are capable to form stable hydrogen bonded dimers between the molecules. As a consequence, the molecules are closer and the hydrogen bonds are stronger in comparison of alcohol. So COOH ni dia lebih stronger than OH. So the carboxylic acids has higher boiling points than alcohol. So COOH have the higher boiling point than OH. Which compound has the higher boiling point? Okay, first thing first, kita kena tengok functional group dia. So dia COOH. Lepas kita kira 1, 2, ada 3. So dia adalah Propanoic acid. Okay, ni kita kena tengok functional group dia OH. So mesti ada alkohol. Lepas tu kita kira dia ada berapa karbon. Ada 3. So sini adalah propanol. So propanoic acid and propanol can form hydrogen bond between molecules. But propanoic acid has higher boiling point because it can form stable hydrogen bonded dimers. Okay, ni kan kita kata dia ada dimers. Yang ni tak ada dimers. So ni lebih stable berbanding yang ini. Sebab itulah boiling point dia lebih tinggi berbanding alcohol. The presence of dimers in propanoid increase the strength of hydrogen bond, resulting in high boiling point. So the second one is effect of molecular size in boiling point. Which compound has higher boiling point and explain? Okay, ni kan ethanoic acid. Ethanoic acid. Dan yang ini ada 1, 2, 3, 4, 5. So ni pentanoic acid. So both pentanoic acid and ethanoic can form same number of hydrogen bond. Kenapa? Sebab dua-dua ada satu je functional group between the molecules. But pentanoic acid has higher number of carbon. Dia lagi banyak carbon kan. Hence bigger molecular size. So size dia lebih besar berbanding ethanoic. So the bigger molecular size, the stronger van der Waals force. Sini punya force lebih tinggi berbanding ethanoic. Thus pentanoic acid has higher boiling point. So boiling point dia lebih tinggi berbanding boiling point ethanoic. So the effect of branching in boiling point. Compare the boiling point for the following carboxylic acid and explain. Okay, ni 1, 2, 3, 4, 5. So ni adalah pentanoic acid. Okay, sini kita tengok dia ada branch kan. Tapi dia sini pun dia tetap COOH. Okay, kita tengok dia ada berapa carbon ada 1, 2, 3, 4, 5. So sini pun dia ada 5 juga carbon. Dan dia ada 1 juga COH. Tapi ni dia ada branch. So nama dia akan jadi 3,3-dimethyl 2-oxo-butanoic acid. Okay, ni nama dia Okay. Basically pentanoic acids and 3,3-dimethyl and 3,3-dimethyl 2-oxo-butanoic acid has same molecular size and can form the number of hydrogen bond between the molecules. But pentanoic acid has higher boiling point due to the bigger surface area in contact. Sebab dia less branching compared to 3,3-dimethyl 2-oxo-butanoic acid. Sebab sini kan straight chain, tapi sini dia ada branch kat sini. So sini lebih besar daripada sini. Sini lagi besar. So dia punya van der Waals forces kat sini lebih tinggi berbanding kat sini. Sebab sini kan lebih besar daripada yang ni. And thus higher boiling point. So sini dia punya boiling point is higher than dekat sini. The presence of hydrogen bonding in solubility of carboxylic acid in water. Carboxylic acid C1 until C5 is more soluble than alcohol of same hydrophobic area, since carboxylic acid can form more hydrogen bond with water. Solubility of carboxylic acid decrease with the increasing size of alkyl group in the molecule because of larger hydrophobic area. So as we know, carboxylic acid ni dia macam ni. Okay, sini ialah alkyl group. Sini dia hydrophobic. Okay, yang ni pula carboxyl group. Dia hydrophilic. Okay, hydrophobic. Phobia. So dia tak suka air. Hydrophilic. Light. So dia suka air. Okay, so carboxylic acid, solubility of carboxylic acid will decrease with the increasing of alkyl group. Sebab alkyl group ni kan dia tak suka air in the molecule because of the larger hydrophobic area. Dia kan tak suka air. So sebab itulah solubility ni dia decrease. Solubility of carboxylic acid increase with the increasing number of COOH group because more intermolecular hydrogen bonds are possible with water molecules. So COOH ni kan hydrophilic, and hydrophilic ni dia can form hydrogen bond with water molecule. So sebab itulah solubility carboxylic acid akan increase bila ada banyak COOH group. Okay, jom kita tengok example dia. Compare the solubility of the following carboxylic acid. Okay, ni ada 1, 2, 3, 4, 5. So dia pentanoic acid. Okay, ni ada 1, 2, 3. So dia propanoic acid. Okay, pentanoic acid is less soluble in water than propanoic acid. Solubility of carboxylic acid decrease with the increasing size of alkyl group. Okay, tengok ni kan banyak alkyl group. Dia kan ada banyak. Nampak ni. Yang ni dia ada sikit je alkyl group. Sebab itulah yang ni dia punya solubility dia lebih rendah daripada yang ni. Sebab alkyl group ni kan hydrophobic area. So pentanoic more acid, more number of carbon than than propanoic acid, hence larger hydrophobic area. So macam yang saya cakap lah, sebab ni lebih banyak alkyl group kan daripada yang ni. Proceed with subtopic 7.4, which is preparation. So the learning outcomes for today is, at the end of this lesson, students should be able to explain the preparation of carboxylic acid through the oxidation of primary alcohols and aldehydes. Okay, the preparation of carboxylic acids from oxidation of primary alcohol and aldehyde. So the first one kita tengok of primary alcohol. Okay, kita tengok dari sini. Oxidation reaction of primary alcohol with weak oxidizing agent, which is PCC, will produce aldehyde. So sini adalah aldehyde. When aldehyde undergoes further oxidation, will produce carboxylic acid. So sini barulah carboxylic acid. So oxidation of aldehyde, oxidation reaction of primary alcohol with strong oxidizing agent will produce carboxylic acid. So example show the synthesis of propanoic acid from propanol. Okay, first thing first, kita kena lukis dulu structure dia. 1, 2, 3. 1, 2, 1, 2, 1, 2, 3. Okey, mula-mula yang hidrogen yang ni kita boleh potong dan gantikan dengan OH. OH ni pula kita kena potong dan gantikan dengan double bond O. So nanti dia yang H ni pun kita boleh potong juga. So nanti dia akan jadi C1, 2, 3, C1, 2, dan sini kita akan jadi C double bond O, sini OH. So sebab itulah dia dapat propanoic. Okay, that's all. Thank you.
Okay, ada soalan tak? Ada soalan? Okay, ikut survey saya ni. Okay, kehadiran kelas 5 ES 15 14 orang, 03 13, 07B 8 orang. Okay, yang tak hadir tu nanti saya akan carilah. Okay, kat mana dia saya akan terus isi dalam sistem lah, you tak hadir kelas. Okay, so kita teruskan dengan kumpulan dari kelas 103. Okay. Ah, 07B dia tak buat yang ni sebab dia ahli kelas dia tak ramai. Okay, dia dah buat habiskan sampai chapter 6. Okay, ni grup Sabarudin. Okay, dengar dia punya penjelasan dia punya penerangan.
Hi, Assalamualaikum. We are from group 7. Today we will discuss about physical properties of carboxylic acid. These is my team members. So physical properties of carboxylic acid can be divided by 2. First one is boiling point for carboxylic acid. We have two conditions that we are going to look at. The first condition is comparison within carboxylic acid. The second one is comparison with alcohol. Next physical properties is solubility in water. Factors affecting the property strength is the ability to form hydrogen bonds with water. Now we look at factors of boiling point of COOH. The first factor is numbers of alkyl group or numbers of carboxylic acid group. When the number of carboxylic acid group increase, the stronger the hydrogen bond. Therefore, boiling point will also increase. The second factor is molecular size or numbers of carbon. When the number of carbon increase, the molecular size also will be increased. Therefore, it leads to boiling point also will be higher. The third factor is molecular surface area. When the molecular surface area larger, the boiling point also will be increased. Now we look at a boiling point of alcohol. The factors is number of hydrogen points, which hydrogen points are stronger between carboxylic acid and alcohol. For example, in here, ethanoic acid and propanol. So, the ethanoic acid and propanol both can form hydrogen bond with itself. However, ethanoic acid are more stable and stronger hydrogen bonds through dimerization than propanol. So more energy needed to overcome the stronger hydrogen bond in ethanoic acid. Thus, boiling point in ethanoic acid is more higher than propanol. Solubility can be divided by two categories. First one is hydrophilic area and the second one is hydrophobic area. As we know, hydrophilic area is the mean which is love water and the hydrophobic area means hate water. So more hydrophilic group, the higher the solubility. Lesser hydrophobic group, the lower the solubility. Solubility of carboxylic acid decreases with the increasing size of alkyl group in the molecule due to the larger hydrophobic area. For example, ethanoic acid has smaller alkyl group than pentanoic acid, means that ethanoic acid is more hydrophobic than pentanoic acid and more soluble in water. Preparation of COOH can be divided by two. First one is strong oxidation of primary school, which means strong is the keyword which lead to strong oxidizing agents. And the second one is oxidation of aldehyde. So, for example of strong oxidation agent is potassium dichromate and potassium permanganate. Look at the strong oxidation of primary alcohol example. So, as you can see, the carbon that holding OH is only a primary carbon. Therefore, is a primary alcohol will undergo strong oxidation by using potassium permanganate in acidified condition with heat. During the process, the OH will be removed and will be replaced by double bond O, and one of the hydrogen that is still bonded to the carbon that holding to the OH will also be oxidized and become OH. The R group will be remain unchanged because nothing is changing and the carbon will still be there. Now we look at an example of oxidation at the height. The the oxidation at the height, the hydrogen will be removed and replaced by OH, and that is the oxidation of aldehyde. That's all from us. Thank you.
Okey, ada soalan? Anyone? Ada soalan? Grup Sabarudin ni? Sabarudin tak ada dalam ni. Saya tak salah. Saya tahu siapa ada, siapa tak ada. Saya check juga. Okey. Okey. So, kita pergi seterusnya untuk chapter subtopik yang terakhir. Okey. 7.5. Okey, kita dengar extension dari grup Anisai. Okey. Ingat reminder saya, tolong jangan copy link kehadiran ni ke dalam ke tempat lain. Okey. Siapa yang join je yang akan dapat link ni. Okay, thank you. Kalau ada yang dia punya nama ada double tu, ataupun dikantoi, tinggallah.
Of carboxylic acid. So in this video, we are going to cover 4 different chemical reaction of carboxylic acid. The first one is reaction with group 1 metal. The second one is reaction with group 2 metal. The third one is esterification. And the last but not least is neutralization with base. So let's jump straight into the reaction carboxylic acid with group 1 metal. So the group 1 metal that I have over here is sodium and also potassium. So kita akan fokus on carboxylic acid group sebab dia yang akan react with sodium. Who will actually react with sodium? It's actually OH over here. Apa perubahan yang berlaku di OH? Okey, ini ialah hydrogen. So when I remove H over here, the H will become H plus and O will become O negative, O minus. And Na, we already know that Na plus. So when I remove H over here, so Na plus will replace the H plus that removed from OH. Rest of the things that does not change shall remain unchanged. The R group will be there. The carbon double bond O shall remain unchanged. And the O will be there and A will replace H. Hydrogen will then remove as a hydrogen gas. So let's see another example. It will be exactly same with the example 1. So kita akan fokus dekat group carboxylic acid, terutamanya hydrogen on the OH. Hydrogen will be removed and replaced by potassium plus. And again, that does not change, shall remain unchanged. But you have another way of writing. You can write it in the form of charge. Like this, O minus, K positive, byproduct will still remain hydrogen gas that you remove from OH. Kind of reminder, if not having charge on O and Na, both shall not charge. But if you having charge, for example like this, you need to put O minus K plus. Okay, let's see reaction carboxylic acid with group 2 metal. Kita ada dua contoh group 2 metal, iaitu magnesium and calcium. Sama je macam tadi. So let's see first example. We'll still focus on the hydrogen that attached with O. Hydrogen will be removed, but we know that H positive and O minus. Since it's a group 2 metal, your magnesium become magnesium 2 plus. So kita ada positif 2. How many O minus I need? I will need 2 O minus to balance off with the 2 positive. That's why yang ni tak berubah, cumanya kita kena ada 2 untuk bonded dengan 1 magnesium, and byproduct that you found would be hydrogen gas. Okay, understand? This example is the same like example 1, so I don't need to explain anymore. Okay, so that's all from me. Thanks. I will pass to the second presenter.
Assalamualaikum and hi everyone. My name is Estrification binti Rusdi. So today we will learn about subtopic in 7.5, Estrification. Okay, so the things that we form in Estrification is ester. We're definitely using the COOH over here, and kita reacting with alcohol with the presence of acid, so we will get ester. So let's see what happened. First, kita fokus dekat COOH, focus on the carbon that holding the OH. So apa akan jadi? In your COOH, we will remove OH. In your alcohol, kita akan remove the hydrogen that attached to the OH. And this is the carbon that loses the OH, and this is the oxygen that loses the OH. So this, the new bond with this carbon, and this is oxygen. So the rest of the group, the change will remain unchanged. So kita copy je. The R, your carboxylic acid, and this R bonded to the carbon that holding double bond O. So this oxygen will be sitting over here, and the rest that holding the oxygen kita just copy je, and this is the ester that you form. Take note that your ester must be the carbon that have double bond O sama dengan C single bond OC. This is your carboalkoxy group. So itulah kita punya ester yang kita hasilkan. So always remember, kita akan buang OH dekat carboxylic acid, and alkohol kita akan buang H. So yang kita buang ni akan jadi apa? Definitely ia akan jadi H2O. Understand? So let's look at the next example here. We have the carboxylic acid. I have my OH. So kalau kita expand this COOH, actually dia C double bond O, single bond OH. And remember that dalam proses esterification, kita akan guna acid iaitu H+. Also we were going to remove water. So dalam esterification ni kita akan buang air. The carboxylic acid will be the one who remove OH, while alcohol akan remove H. So the new bond will be formed between the carbon yang kehilangan OH tadi and the oxygen that loses the H. So kita ambil semula the benzene and C double bond O, and then a new single bond with the O yang daripada alcohol tadi. Next kita just copy the whole thing. So this is from the alcohol and this part from your carboxylic acid. So don't forget the product is H2O yang kita buang daripada carboxylic acid and alcohol tadi, alright? This is the formation of ester. Hi, so the last one in subtopic 7.5 that I will tell you right now is about the neutralization of carboxylic acid with the base. Okay, but first we must know that the base that we're talking about here is the first one. We got this NaOH, which is our sodium hydroxide, and the second one we got NaHCO3, which is our sodium bicarbonate, and the last one here we got our Na2CO3, which is our sodium carbonate. Okay, so today we will be focusing on the COOH, which is our carboxylic acid, obviously, but to be more specific, we don't really focus on the overall COOH, but rather we're focusing on the hydrogen that is sitting with the OH right here. So the hydrogen right here is actually our main character for today lah kan. Okay. The changes that we will see right here is actually very similar as what one of my group mates, which is Putri, have explained earlier with the reaction with group 1 metal. We're actually looking at the changes between the hydrogen and sodium. Okay, and as we know, sodium is in group 1, which makes it become Na+, and H+ will be removed. So we will replace the hydrogen with the sodium. So our product that will be produced in this reaction will be R C double bond O will be remain unchanged, but the changes will happen to the OH. So the OH earlier will become O and A right here, and the byproduct that will be produced in this reaction is H2O right here. Okay, why H2O? Because we have the H that we have removed from the OH, and we also have the OH from our NaOH. So H plus OH, so we will get H2O. So that's why we get the H2O as our byproduct for this reaction. Next, if we react it with sodium bicarbonate, the product that will be produced is basically the same. R C double bond O will be remain unchanged, and our OH will become O and A. But the only thing that is different here is our byproduct. So we will have H2O and CO2 as our byproduct. we have carbon dioxide as our byproduct is due to the presence of CO3 here. Okay. And lastly, if we react it with sodium carbonate, basically the same outcome will be produced, which is RC double bond O, and our OH will become O and A, and the byproduct will become H2O plus CO2, the same as we react with our sodium bicarbonate just earlier. And this CO2 will become the byproduct is due to the presence of our CO3 right here. So yeah, that's it. So I think that's all from us. Thank you for watching.
Okay, very good and clear explanation untuk chemical properties ni. Okay, very good lah. Okay, so dia diterangkan bagi example. Okay, so kita proceed dengan apa tu, group yang terakhir. Okay, dari kelas 03. Okay. Okay, dari group Yushami Yushami group. So, okay, listen to the explanation. Oops. Okay.
Hi guys, my name is Hakim. I am the representative from Group G. My group consists of me, myself, Abang Hakim, Yushami, and also Nufadlina Hani. So today I would like to present subtopic 7.5 chemical properties of carboxylic acid. Learning outcome for this subtopic. The first one, student must know the reaction between group 1 metal. Second one, reaction between group 2 metal. Thirdly, Accelerification, and lastly, Neutralization. So the first one, reaction with group 1 metal. So firstly, we must know which one needs to be break. So given here is the carboxylic acid. So firstly, we must break OH bond over here. So O over here will combine with group 1 metal. So here we use Na as group 1 metal. So carboxylic acid react with group 1 metal, Na will produce ONA here. So where does the H goes? So H will transform into gases and become H2 gases. Because this reaction involves group 1 metal, so to balance the equation, we need to plus 1 over 2 here, so that the equation will be stable. So for example here, we have 2-pentyl propanoic acid react with Na sodium here. So firstly, as I said before, we must break OH bond over here. And then O over here will combine with the group 1 metal over here and produce O and H over here. So H will transform into H2 gases, and we need to put 1 over 2 in front of H2 gases to balance the equation. The famous group 1 metal that always been used is sodium and kalium. So next one. So for group 2 metals, it almost the same from group 1 metal, but it has different in the writing the equation. So first and foremost, we must break the OH bond over here first, just like the group 1 metal, and just copy all of this to here and put bracket outside over here, and the group 2 metal must be outside the bracket like this. Mg is outside the bracket, and don't forget to put 2 outside because this equation involves group 2 metal. Since this group 2 metal is already stable, so we don't need to put 1/2 in front of H2 gases. For example, here we have benzoic acid react with barium. So first and foremost, as I said before, we must break the OH bond first. And copy back all of this to here. And don't forget to put the bracket over here. And put the group 2 metal outside the bracket like this. We put Ba outside the bracket and put 2 outside also. And don't forget to put H2 as gases. So now we're moving on to the third chemical reaction, which is acerification. So acerification, we already know it involves carboxylic acid and alcohol. Because we already learned in chapter 5 alcohol, acerification reaction. So the product that will be formed is ester over here and also water. So carboxylic acid will reduce OH over here, while alcohol will only take H over here. So when both of these combine, it will produce H2O or water. And then we just combine the rest over here and also the alcohol that remain and form ester over here. So the most important part in this reaction is we must know the acid catalyst and also the condition of the reaction. So the acid catalyst that we use either concentrated H2SO4, H plus or mineral acid, while the condition must be heat or reflux. So for example, here we have benzoic acid react with methyl propanol. So here we have the acid catalyst is H plus and the condition must be heated or reflux. So carboxylic acid will reduce OH over here, while alcohol will breaks OH bond over here. When both of these combine, it will produce H2O. And we just copy back the remaining carboxylic acid and also the alcohol to form ester. And the last one is neutralization with bases. During SPM, we already learned neutralization is involved for acid plus bases, and the product is salt plus water. So here we have the acid, which is carboxylic acid. So we must break OH over here first into 2 And also the bases, we take both OH here. And when these two combine, it will produce water over here. And the Na will combine with O over here to produce ONa. Same goes to hydrogen carbonate and sodium carbonate. For hydrogen carbonate here, we have CO3. So the product will form also is carbon dioxide, CO2. It's just the same. We must break first the OH here, and we take all of this. So when this combine, it will produce H2O and also CO2, carbon dioxide and water. And we just copy back the remain over here. So here we have the example for neutralization. So first and foremost, as I said before, we must break the OH over here first. Then we must take OH over here. When both of these combine, it will produce H2O. And then O over here will combine with Na here. And we just copy back this compound over here. And it will produce salt plus water. The same goes to NaHCO3 over here. So firstly, we break OH here first. And then we take this HCO3 and we combine it and we produce H2O plus CO2, water plus carbon dioxide. So the remain compound we just copy back and we write it here. Na. So same goes to Na2CO3 also. You guys can try it now. And lastly, that's all for my group. Thank you for lending your ears and have a nice day.
Okay, very good explanation. Boleh tengok kat komen, orang yang komen kat tepi ni. Okay, kalau you rasa perlu discuss balik tak dengan saya untuk topik ni, ataupun kalau boleh, kalau you nak discuss balik, bagi satu like. Kalau tak nak discuss, you boleh faham sendiri daripada pendaran kawan-kawan awak. Awak boleh bagi dua like so boleh saya tengok daripada situ. Okay, respon dia sebenarnya nak check attendance juga ni. Okay, siapa yang respon tu kira dia hadirlah di akhir sesi kita ni. Okay, so boleh saya tunggu boleh respon sekarang. So habislah kita punya kita punya topik chapter 7. So saya tunggu you punya respon untuk kita proceed kelas kita macam mana esok. Sama ada perlu discuss balik atau tak. Okay, so saya harap semua boleh faham dan tengok baliklah video kawan-kawan awak ni. Okay, dah memang ada save dalam YouTube. So you boleh ambil masa, lepas ni ada masa lagi kan. Okay, ada masa dalam 40 minit lagi. Okay, boleh tengok balik, cuba fahamkan. Dah boleh start buat tutorial. Okay, tutorial pun nanti saya akan bagi agihkan untuk you all letak dalam group nanti. Saya akan buat satu group lain untuk chapter 7. Okay, so saya masih tunggu respon kamu. Okay, so yang hadir ni ada 42 orang. Okay, tolong respon. So ada 22 respon kat sini. Okay, saya akan check 3 kali saya check attendance. Orang yang isi kehadiran tu dia tak boleh nak tipu saya. Okay, yang hadir sampai ke hujung ni saya akan tahu siapa. Okay, kalau perlukan discussion boleh like 1 kali. Kalau tak perlu 2 kali. Okay, So saya rasa itu saja kot untuk hari ini. Okay, bolehlah untuk you self-assess learning, you boleh baca sendiri dulu, tengok video dulu, and then so keputusan dia apa ni? Amboi, kalau tengok kat komen ni semua like satu kali Okay, so untuk kelas esok kita akan recall balik. Okay, kita akan discuss balik apa yang kawan awak dah present hari ni. Saya akan bagi enforcement lah. Okay, macam biasa. Okay, so thank you class. Okay, see you tomorrow. Okay, get ready dengan kita punya Google Meet. Okay, don't be late Okay, bye. Thank you.